Hello everyone, after a break I'm back, and as I promised last time that we will solve the exercise of chapter 1, so here we are. Let's begin solving exercise of chapter number 1 from grade 11 chemistry book. So here we are with the first question. Select the most suitable answer in the following MCQs. So these are some of the MCQs given, and we will solve all of them one by one. So the first question is, how many molecules are there in 1 mole of water? So you already know that 1 mole of anything is equal to Avogadro's number of molecules, and Avogadro number is 6.023 into 10 to the power 23. So 1 mole of water will obviously contain 6.023 into 10 to the power 23, and so you can find it here. So option B is the correct option for question number 1. Second question, a flask contains 500 centimeter cube of sulfur dioxide at STP. The flask contains A, 40 grams, B, 100 grams, C, 50 grams, or D, 1.427 grams of sulfur dioxide. So we have to do a little bit of calculations, and you already know that 22.4 dm cube of gas is occupied by 1 mole of any gas. And here we have sulfur dioxide, the gas. But you have to give the answer in grams. So for that, we have to convert 1 mole of sulfur dioxide into grams. And for that, we need the molecular mass of sulfur dioxide. So if you remember, the atomic mass of sulfur is 32 and that of oxygen is 16 multiplied by 2. That is also equal to 32. So this is equal to 64, which means that 1 mole of sulfur dioxide is equal to 64 grams of sulfur dioxide, which means that 22.4 dm cube volume will be occupied by 64 grams of sulfur dioxide. But what we have is 500 centimeter cube. So how many grams of sulfur dioxide would be there? So first you have to convert 500 centimeter cube into dm cube, because we need the same units in the question. So 500 centimeter cube is equal to 0.5 dm cube. You can see the conversion formula for these two. So if 22.4 gram, if 22.4 dm cube volume is occupied by 64 grams of sulfur dioxide, so 0.5 dm cube will be occupied by 64 into 0.5 divided by 22.4, and this is equal to 1.428 grams. Let's see the answers. So we have 4 answers: 40 grams, 100 grams, 50 grams, and 1.427 grams. This looks the closest, so this would be the answer. That is option D is the correct option. Let's go down to question number 3, which states that a necklace has 6 grams of diamond in it. What are the number of atoms in it? You know that diamond is carbon and the atomic mass of carbon is 12. So 12 grams of carbon is equal to 1 mole. So 6 grams of carbon would be 0.5 moles. And you know that 1 mole of anything contains Avogadro number of atoms. So half of the moles will have half of the number of atoms. And if you look at these answers, this is Avogadro number, so it can't be this. And if you go down to D, 3.01 into 10 to the power 23 is half of the Avogadro's number. 6 grams of diamond is equal to half of the moles, and half of the moles will have half of the number of atoms as that of the Avogadro's number. So D is the correct option in this case. Okay, what is the mass of aluminium in 204 grams of aluminium oxide? Again, this needs some calculations, so let's do the calculations. The options are 26 grams, 27 grams, 54 grams, and 108 grams. So mass of aluminum oxide that is given to us is equal to 204 grams. And we have to find the mass of aluminum in 204 grams. For that, we need to calculate the molecular mass of aluminum oxide first. And you know that the atomic mass of aluminum is 27. So 27 multiplied by 2 is equal to 54. And we have 3 oxygens, so 16 multiplied by 3 is equal to 48. So this is equal to 12, and this is 10. So 102 grams of aluminum oxide is equal to 1 mole of aluminum oxide. And you know that 1 mole of aluminum oxide contains 2 moles of aluminum, and that is equal to 54 grams. So, and that you can see here as well. So out of 102 grams of aluminum oxide, we have 54 grams of aluminum. So if 102 grams of aluminum oxide contains 54 grams of aluminium, then 204 grams of aluminum oxide would contain 54 multiplied by 204 divided by 102, and this is equal to 108 grams of aluminum. Let's see the options: 26, 27, 54, and 108. So D is the correct option. Question number 5. The reactant which is consumed earlier and gives least quantity of product is called the reactant in excess, stoichiometry, limiting reactant, stoichiometric amount. So you already know that the reactant that is present in lesser molar ratio, or which is consumed earlier, or which gives the least quantity of the product, is called the limiting reactant. So in this case, option C is the correct option. Question number 6. Which one of the following compounds contains the highest percentage by mass of nitrogen? So we have already done the calculations for determining the percentage composition of molecules. So we have ammonia, N2H4, NO, and ammonium hydroxide, and we have to calculate which one of these has the highest percentage of nitrogen by mass. So first we have ammonia, and the total mass of ammonia is equal to 17, and out of 17 we have 14 grams of nitrogen. So 14 divided by 17 multiplied by 100 is equal to 82.35%. Then we have N2H4. So if you calculate the mass, this is equal to 14 into 2 is equal to 28 plus 4, that is equal to 32. And out of 32, we have 28 grams of nitrogen, multiplied by 100. This is equal to 87.5%. Then we have NO, and this is equal to 14 plus 16 is equal to 30. Out of 30 we have 14 for the nitrogen, so this is equal to 46.6%. And then we have ammonium hydroxide, which is equal to 14 plus 5, 19 plus 16, 35. So out of 35 we have 14 for the nitrogen, multiplied by 100, this is equal to 40%. And so you can see that among all of them, N2H4 has the highest percentage, and that is our option number B. So this is the correct option. Question number 7. Vitamin A has a molecular formula C20H30O. The number of vitamin A molecules in 500 milligrams of its capsule would be 6.023 into 10 to the power 23, 1.05 into 10 to the power 21, 3.01 into 10 to the power 22, and 3.01 into 10 to the power 23. So again, we have to calculate the number of moles in 5 to 100 milligrams of vitamin A, and for that we need the molecular mass of the compound. Let's calculate again. So we have 20 carbons, so one carbon is 12, and 12 into 20 is equal to 240. We have 30 for the hydrogens and 16 for oxygens, so a total is 286, and we have 500 milligrams. So which means that 286 grams is equal to 1 mole of vitamin A. And if you convert 500 milligrams into grams, this is equal to 0.5 grams. And this would be equal to 0.5 divided by 286, and which is equal to 0.00174 moles. So you know that 1 mole of anything is equal to Avogadro's number. So 0.00174 would be equal to the same number multiplied by the Avogadro's number. So this is equal to 0.0105 into 10 raised to the power 23. So this would be equal to 1.05 into 10 raised to the power 21 molecules of vitamin A. Let's see if we have this option there. Yes, we have the option 1.05 into 10 raised to the power 21, which is option B, the correct option. Question number 8. When 1 mole of each of the following is completely burnt in oxygen, which will give the largest mass of carbon dioxide? We have carbon monoxide, diamond, ethane, and methane. Let's see the combustion reactions of all of them. So if we have carbon monoxide that reacts with oxygen, it will give carbon dioxide. We have to balance the equation. We have 3 oxygens here and 2 here. So if you multiply this with 2 and then multiply this with 2, then the reaction would be balanced. If we have methane that reacts with oxygen, this will produce carbon dioxide and water. Again, you have to balance the equation. So we have 2 oxygens here, we have 3 here. So you multiply this with 2 and then you multiply this with 2, and now it is balanced. If we have diamond, that is carbon reacting with oxygen, so this is carbon dioxide. It's already balanced. And the last one is ethane, C2H6 plus oxygen, and this will give carbon dioxide plus water. Again, we have to balance. We have 6 hydrogens here, so you have to multiply this with 3. That makes 5 oxygens here. We cannot have 5 here, so for that you need to multiply this with 2 to make 2 carbons here. And now we have 4 plus 1, 5 oxygens, and you have to multiply this with 3. So now we have 7 of them. And okay, so the final equation would be 2 moles of C2H6 plus 7 moles of oxygen, leading to 4 moles of carbon dioxide and 6 moles of water. Let's go back to the question, what it states. After combustion of all of these 4, which one will give the largest mass of carbon dioxide when 1 mole of each of the following is completely burnt? So when 1 mole of carbon monoxide is completely burnt, it will give 1 mole of carbon dioxide, that is 44 grams of carbon dioxide. Okay. And when 1 mole of methane is burnt, it gives 1 mole of carbon dioxide. So again, that is 44 grams of carbon dioxide. When 1 mole of diamond is burnt, it gives 1 mole of carbon dioxide, and that is 44 grams of carbon dioxide. Here, when 2 moles are burnt, it gives 4 moles of carbon dioxide. So when 1 mole of ethane is burnt, it will give 2 moles of carbon dioxide, and that is equal to 88 grams of carbon dioxide. So which means that ethane upon burning with oxygen will give the highest mass of carbon dioxide when 1 mole of it is burnt. So the correct option is ethane C2H6. Question number 9. When 1 mole of ethanol and 1 mole of ethane have an equal mass, number of atoms, number of electrons, number of molecules. The question is 1 mole of ethanol, ethanol is a molecule, and 1 mole of ethane, ethane is a molecule. So 1 mole of anything, of any molecule, will have the same number of molecules. So option D is the correct option. They don't have equal mass, they don't have equal number of atoms, they don't have equal number of electrons, but they do have equal number of molecules, and both of them would be equal to 6.023 into 10 to the power 23. That is Avogadro's number. Question number 10. Methane reacts with steam to form hydrogen and carbon monoxide as shown below. What volume of hydrogen can be obtained from 100 centimeter cubes of methane at the standard temperature and pressure? Now, this is a reaction between methane steam giving carbon monoxide and hydrogen, and we have to calculate the amount of hydrogen in volume if 100 centimeter cubes of methane react at standard temperature and pressure. So you already know that 1 mole of any gas occupies 22.4 dm cube of that gas. So if we have 100 centimeter cubes of methane, we have to convert first this into dm cube and then calculate the number of moles of methane from that, and then from the balanced chemical equation we have to calculate the amount of hydrogen produced in grams and number of moles, and then from that we can convert the moles back into volume and then see what we have. So let's do the calculations. So we have methane reacting with steam to produce carbon monoxide and 3 moles of water. And from the balanced chemical equation you can see that 1 mole of methane produces 3 moles of water. So which means that 22.4 dm cube of methane will produce 3 into 22.4 dm cube of hydrogen, and this is equal to 67.2 dm cube of hydrogen will be produced as a result. Now we have 100 centimeter cube, and this is equal to 0.1 dm cube. So if 22.4 dm cube produces 67.2, 0.1 dm cube will produce 0.1 into 67.2 divided by 22.4, and this is equal to 0.3 dm cube, or in other words this is equal to 300 centimeter cube of hydrogen. Let's see the options, and here we have option A is 300 centimeter cube, so this is the correct option. In fact, you can do it directly from the balanced chemical equation here as well. So 1 mole gives 3 moles, so 100 centimeter cube will give 300 centimeter cube. Okay, question number 11. The Avogadro's constant is the number of atoms in 1 gram of helium, molecules in 35.5 grams of chlorine, electrons needed to deposit 24 grams of magnesium, atoms in 24 grams of magnesium. The atomic mass of helium is 2. So 1 gram of helium will contain half of the Avogadro's number. The atomic mass of the ionic mass of chloride is 35.5, but it is not molecule. Electrons needed to deposit 24 grams of magnesium, atoms in 24 grams of magnesium. Now the atomic mass of magnesium is 24. So 1 mole of magnesium is equal to 24 grams, and that means that it is equal to Avogadro's number. So the correct option is D. Question number 12. How many moles of oxygen are needed for the complete combustion of 2 moles of butane? So let's write the balanced chemical equation. Butane is C4H10, and if you react it with oxygen, this will give carbon dioxide and water. We have to balance it. So the final equation is 2 moles of C4H10 will react with 13 moles of oxygen to produce 8 moles of carbon dioxide and 10 moles of water. The question is, how many moles of oxygen are needed to complete combustion of 2 moles of butane? You can see that 2 moles of butane will react with 13 moles of oxygen to completely convert into carbon dioxide and water, and we have 13 here, so D is the correct option. Question number 13, if 4 moles of sulfur dioxide are oxidized to sulfur trioxide, how many moles of oxygen molecules are required? So again, let's write the chemical equation. We have to balance it. Sulfur dioxide plus oxygen leads to sulfur trioxide. So we have to do the calculations. If you write 2 here, then 2 here. So this is 6 oxygens here, 6 oxygens here, 2 sulfur and 2 sulfur. And the question is, if 4 moles of sulfur dioxide are oxidized to sulfur trioxide, how many moles of oxygen molecules are required? So for 2 moles, we need 1 mole. So for 4 moles, we would need 2 moles of sulfur dioxide, and we have 2 here. So the correct option is D. Question number 14. The relative atomic mass of chlorine is 35.5. What is the mass of 2 moles of chlorine gas? So in chlorine gas, we have 2 chlorine atoms. So 1 mole of Cl2 is equal to 71 grams. So 2 moles would be equal to 71 multiplied by 2, and that is 142. So option A is the correct answer. Question number 15. Which of the following statements is incorrect? Which means that 3 of them would be correct and 1 of them would be incorrect. So 12 grams of carbon gas contains 1 mole of atoms. Okay. 28 grams of nitrogen gas contains 1 mole of nitrogen molecules. Okay. 1 dm cube of a 1 mole per decimeter solution of sodium chloride contains 1 mole of chloride ions. So 1 mole per dm cube means that in 1 dm cube we will have 1 mole of sodium chloride, and 1 mole of sodium chloride upon dissociation produces 1 mole of sodium ions and 1 mole of chloride ions. So 1 dm cube of 1 mole per dm cube solution of sodium chloride will have 1 mole of chloride ions and 1 mole of sodium. So this is also correct. So which means none of the above statements is incorrect. All of them are correct because 12 grams of carbon is 1 mole of atoms, 28 grams of nitrogen gas is equal to 1 mole of nitrogen molecules. Question number 16. 1 mole of propane has the same number of hydrogen atoms as 1 mole of methane, number of carbon atoms as in 1 mole of butane, mass is half a mole of hexane, number of molecules as in 1 mole of ethane. So 1 mole of propane has the same number of molecules as anything that is 1 mole. So option number D says that the number of molecules of propane is equal to the number of molecules in 1 mole of ethane. So that means it is correct. So option D is the correct option. Question number 17. What is the mass of 1 mole of iodine molecules? So the atomic mass of iodine is 127. So iodine I2 is equal to obviously 254 grams. Option A is correct. What volume of sulfur dioxide at room temperature and pressure is produced on heating 9.7 grams of zinc sulfide if reaction takes place as follows? So 2 moles of zinc sulfide react with 3 moles of oxygen to produce 2 moles of zinc oxide and 2 moles of sulfur dioxide. Option A 1.2 dm cube, 2.4 dm cube, 3.6 dm cube, and option D is 4.8 dm cube. So we have to determine the volume of sulfur dioxide that is produced on heating 9.7 grams of zinc sulfide if the reaction takes place as follows. So from the balanced chemical equation, you can see that 2 moles of zinc sulfide will produce 2 moles of sulfur dioxide. So first we have to convert 9.7 grams of zinc sulfide into the number of moles. So the molecular mass of zinc sulfide is equal to 97.47, and we have 9.7 grams, and this is equal to 1 mole. So 9.7 grams would be equal to 0.1 mole. So from the balanced chemical equation, we can see that 2 moles of zinc sulfide produce 2 moles of sulfur dioxide. So 0.1 mole will produce 0.1 mole of sulfur dioxide. 1 mole of sulfur dioxide is equal to 32 plus 32 is equal to 64, and 0.1 would be equal to 6.4 grams of sulfur dioxide, which means that 9.7 grams of zinc sulfide will produce 6.4 grams of sulfur dioxide. But we have to calculate the volume of sulfur dioxide produced, and that we can do from the number of moles. So 1 mole of sulfur dioxide is equal to 22.4 dm cube. So 0.1 would be equal to 2.24 dm cube. Let's see if we have this option. Okay, so we have 2.4 dm cube, and that means that this is the closest. So option B is the correct option here. So that's the end of question number 1. We will come back for question number 2. That is the analytical reasoning questions. We have to answer the questions briefly. So I'll see you next time with the second question. Stay tuned, and thank you so much for now.